typical question of what you will see. It does have a little bit of a twist that is a little tricky right here. The figure shows the man running inside a giant hamster wheel with an outer diameter of 8 feet. So outer diameter means just to the outside of the wheel, because apparently this has like some width to it, right? So like from right here to right here, that is 8 feet right there. As the man runs, the wheel rotates in a clockwise direction, completing 2 rotations in 1 second. So that's important to know. We're going to need that. At t equals 0 seconds, point S is located directly above the center of the wheel, 2 feet from the ceiling above the hamster wheel. So the ceiling is 2 feet away from the top of that wheel. As the man runs inside the hamster wheel, the distance between S and the ceiling, there's what's tricky about this, periodically increases and decreases. So we're not measuring the distance from the wheel and the floor, which is what we have done on like any other circle problem that we've had. We're measuring the distance between S and the ceiling. So whenever our point is right up here at the very top, is that a maximum point or a minimum point? It's not a maximum. It is a minimum because we're graphing distance from ceiling. Okay, so it feels like it should be a maximum because everything else we've done, like our Ferris wheel problems and stuff, the top of the wheel was the maximum point. But distance from ceiling, if you're at, if S is at the top of the wheel, then your distance from the ceiling is only 2. If you're at the bottom of the wheel, what's your distance from the ceiling? It's 10. So that looks like it should be a maximum, but it's really a minimum. So we're starting off at a minimum distance. That makes this tricky. Read carefully, and I feel like they wouldn't do that on the actual AP exam, but I can't be guaranteed. We can't be guaranteed on that. If they do, they're going to have a lot of people miss it for that. So we really need to start at like a minimum point. So I am going to extend my graph out a little bit here so that we start right here at a minimum point. That's where my y-axis, or really it's not my y-axis, it's my h of t axis will go. And on that h of t axis, what's the lowest? What's the closest we ever get to the ceiling? That is 2. That's our minimum point. And the furthest away from the ceiling is going to be 10. What's the midline going to be? 6. Halfway between 2 and 10. So that gets all of our y coordinates worked out. And so we got 10 and 10 right here. That middle line is 6 and 6. And then the bottom line right there is 2. All right, to be able to do your x coordinates, you need to know the period of the graph. What is the period of this function? Particularly comes from this right here. It's not 2. It's 2 rotations every second. We want to know how long it takes for 1 rotation. Half a second. All right, so it's half a second. But remember, half a second is not our tick marks, right? So you're going to have a tick mark every time you hit, like, really the t-axis is down here. You're going to have a tick mark every time you're at a minimum. So right here's 0. Then you're going to have like a tick mark here at the midline, tick mark here at F, a tick mark when you go back to midline, at J, at K, and at P. Right? So from like maximum to maximum or minimum to minimum, we've got a distance of 1/2. What do I need to do to figure out where my tick marks need to be? What? Divide by 4. Or you can just do 1. In this case, since it's already a fraction, I would multiply it by 1/4. So each little tick mark is going to be an 1/8. Right? And we're doing that because there are 1, 2, 3, 4 sections that you're breaking up to. It is always going to be a 1/4 for that. So if you take your period and multiply it by 1/4 or divide by 4, whichever one. If it's a whole number, it's easier to divide by 4. Fractions, I would multiply by 1/4. So that means this is 0. This is 1/8. This is 2/8. This is 3/8. 4/8. 5/8. 6/8, and so on, but that's as far as we need to go. You can reduce these if you want. You don't necessarily have to. In this section, a lot of times I don't when I'm counting along the x-axis because it helps me know, 1, 2, 3, 4, 5, 6, 8 there. So this is going to be 2/8, which reduces to 1/4. I think you're fine if you put 2/8 right there. 3/8, 1/2 right here, 5/8 right here, and 6/8, but that'll reduce to 3/4 right here. Okay, everybody all right on that part? What questions do we have? Okay. Now, in order for you to get any real points on Part B, there are some requirements. In order for you to get any real points on Part B, you can mess up Part A, but some things they're looking for is points that are on the same, like, horizontal line. They have to have the same y coordinate, right? Because they have the same y coordinate there. So, like, these right here have to have the same y coordinate. If you don't have that happen, you're pretty much, like, you're kind of out of luck on any of your y values. You can't get your A or your D right for that. Then you also have to have the correct increments. So the other thing you have to have is you have to be counting by 1/8 on that x-axis. If you have those things going on for you, even if you messed up your points here, you could still possibly get full credit on the Part B for that. But if you got crazy stuff happening right there, you've messed up your graph so much there's no equation you can write for it. There, if you've got, like, this is 10 and this one over here is 8, there's not much to do going forward. So you want to make sure you got those things. Always check your horizontal lines, make sure you got the same y coordinates. You want to double check those tick marks. They got to be spaced correctly. So then we're looking for A, B, C, and D. And you actually have a couple options of you have infinite options technically, because you could always shift these like an infinite different amount of ways. What should our A value be? It's going to be 4. What about our D? 6. So if you got those two, you got a point so far on this. Those are the easier ones to come up with. Even if you have them wrong up here, you could still get 1 point there, as long as they are consistent. For your B value, you're going to do 2 pi divided by the period, which is going to be 2 pi divided by 1/2. Dividing fractions is easy as pi. We're going to flip the second and multiply. We get 4 pi. So that is your B. C is where you've got some options because they're asking us to do a cosine graph here. So cosine's y-intercept. Is it usually at a maximum, midline, minimum? Which one is it? It's usually at a maximum right here. So like your dotted graph looks something like this. You can shift it. There's something else you could do. What else could you do? So I could put C as 0. I'm not going to shift it left or right at all. And make A negative. That is what I would do because I think shifting is the most difficult part. So if you put a negative A, it flips this maximum and makes it a minimum point, and then you have the answer. But you don't have to do it that way. Another option is to leave your A a positive 4. B doesn't change. It's 4 pi. D stays the same. It is 6. Your C value, you could shift this to the right 1/4. Or really the left 1/4 would still work as well. So you could put negative 1/4 right here for your C. Or technically positive 1/4 because you could shift it the other direction as well. So you don't have to have like both of these. It could be either one. In fact, you don't want to have both of them. You want to have just a single answer, like single answer for every letter. But either one of these answers could be correct. Yes? It works in this case because your graph starts at a maximum point, so that can be flipped to be a minimum point. But if they had made this a sine graph, wouldn't work. You'd have to shift it left or right. Or if our function maybe didn't start at a minimum point, if it started at the midline, or definitely the maximum. If it started at the maximum, we wouldn't have to shift it at all. But that would be the case. But if it's opposite, if you start at a maximum and you start at a minimum, but cosine is the one you're using, which is supposed to have a maximum, you can flip it for that. Okay, questions? There are definitely times you can't flip, but it is the easier of the options, I think, if it works. Okay. Part C should be a pretty straightforward section. I believe this one asks us about from F to G. So F of G is this section of the graph right here. Is our graph positive or negative? Positive. The whole thing is positive because the x-axis is like down here, right? So it's got to be A or B, no matter what section they ask us about. Is our graph increasing or decreasing? Decreasing. So positive and decreasing is your answer for C. And part 2 on the newer problems is going to be updated. It's going to say what is the concavity and describe the rate of change. Okay, so the concavity here, what do we have from F to G? Concave down. So on the interval T1 to T2, the function h is concave down. And if you say concave down, the rate of change is decreasing. And if your answer is concave down, you need rate of change decreasing. If your answer is concave up, rate of change is increasing. There's never a concave down, but my rate of change is increasing. That won't happen. Okay, so you guys remember these, hopefully. This was first part of Unit 3 before it all went south, so we did pretty well on this whenever you guys had it on the test.